title today, multiplying polynomials. And the question we want to ask ourselves is, how do you do that? How can you multiply two polynomials together? All right. Goals are pretty straightforward, kids. We're going to multiply binomials. Kids, how many terms do binomials have again? Two. Here's the biggie today. Use what method? FOIL. That stands for something. It's an acronym for something I'll show you here in a second. Use the FOIL method. We're also going to multiply some binomials with some trinomials. 2 terms times how many terms here, kids? 3 terms. Okay? So this is going to be pretty much is what it is. You've got to know how to do this before we can move on to other things that are going to be more in depth with this. But guys, FOIL method right here. Do I have a volunteer that would read what our FOIL method is for vocab today first? Go ahead, Sam.
Shortcut for multiplying two binomials by finding the sum products of the first terms, outside terms, inner terms, and last terms.
Okay, so if I had something like this, kids, it's like if I had maybe x plus 2 like this, times, I don't know, maybe 2x minus 6. First of all, we're taking the first binomial. The first binomial is x plus 2. How many terms are in this first set of parentheses? 2. How many terms are in the second set of parentheses? We're going to take one binomial times another binomial. This idea of it is basically saying you got to multiply everything together. And the F stands for, what do you think the F stands for? First. So in each one, what's the first term in each binomial? Okay, so I'm just going to do this. I'm going to draw something like this. This is the first part that you're going to do. Okay. Then, what do you think the O stands for? You're going to do the outside. You're going to take this x times outsides means on the far left and the far right. So this would be, that would be your outside that you're going to multiply together. Well, O is outside, but I think I is inside. So the inside terms are the 2 and the 2x. So here's your inside. And then what do you think L stands for? What are the last terms in each binomial? What's the last term in this first binomial? 2. What's the last one in this one? Okay. Guys, quick question. How many arrows did I draw? 4. If there's 2 terms in the first and 2 terms in the second, what's 2 times 2? What do you think if I take a binomial, 2 terms times a trinomial is going to be? How many terms do you think that'll be when we multiply those together? 6 of them, right? Okay. So that's what that stands for. We'll work on this method today. We're going to look at this method in various ways because there's different ways to do this. Some people see different ways of doing this and they like some of the ideas that we present in this section a little better. So I don't really care what you use. I just want you to be able to multiply binomials. Okay, guys, a lot of the terms right here that are below this I don't really need to go over because it was all from section 2.1. Do we remember what a polynomial is?
Yes.
Okay, it's a monomial or sum of binomials. Specifically, what type of polynomial is 5x plus 2? Binomial, how about the x squared plus 5x plus 2? Specifically, what kind is that? It's a trinomial then, okay? Talk about stuff that's closed, addition, subtraction, multiplication are closed because if you add, subtract, or multiply 2 numbers, you definitely get a number. Division is not closed because sometimes when you divide by 0, does that give you an answer? No. Okay? We know what binomial is, we know what trinomial is, so let's get to this. Guys, multiplying binomials using what? Distributive property. Here's how you do this. We're going to do like we just said up there. Multiply this out and simplify it. First of all, multiplying binomials. When you multiply binomials, what you're really accomplishing, guys, is getting rid of the parentheses first. And then I'm going to say combine like, what word am I going to throw up here next? Terms. Okay, so I'm going to do one and then I'm going to have you guys try some, but let's do this real quickly. Let's see if we can't get that FOIL method down to multiply this out. What does x plus 8 times x plus 2 make? Okay? So let's do the first ones together, kids. What would the first ones be?
X plus
X times x, right? What is x times x, kids? X to the second power, right? How about the outside? What and what?
X and 2.
So I've got a positive x and a positive 2. That would be multiplying to a positive 2x, wouldn't it, kids? Okay, now I'm going to take the insides, which would be 8 times what? Which would be a positive 8x, wouldn't it? And then last, what's last here, kids?
8 plus 2.
What's 8 times the 2? Positive 8 times positive 2 is? Okay. All right, so have we gotten rid of parentheses, first of all? I took 2 terms times 2 terms. How many terms do I have written down so far after I do that? 4. Is that good? Okay, now ask yourself this. Within what you've written down in that first step by getting rid of parentheses, are there any terms that we could choose to put together or make simpler? Ellie? The 2x and the 8x right here in the middle terms would combine, wouldn't they, kids? Usually your outside and inside terms will combine. What is a positive 2x and a positive 8x going to combine to, kids? So in simplest form, when we expand this, this would be x squared plus what? 10x plus 16. Okay. All right, so how many multiplications did I have up here when I did the distributing here, guys? 1, 2, 3, 4. Okay, so you guys try this one on your own. Be careful. When you do this with -5, what kind of 5 are you really multiplying with? -5. You guys try that next one. See what you get. It's simplest form. I'll give you a few minutes here. We have everybody today, don't we, kids? 3, 6, 10, 11, 14. This one's a little trickier than the first one. But I think if you follow the rules and do what you need to do there, you'll be in just fine shape here. Anybody want to talk me through this one at all? What should I start by multiplying, kids? Let's do the first ones in each one.
X times.
So what's x times x going to get me?
X to the second.
X to the second. Let's do the outside, which would be what times what?
X times
So plus or minus 1x. Okay, let's do the insides. What are the insides, guys? -5, the inside, these two inside parts. -5 times x would be minus 5x, wouldn't it, kids? Okay, and then the last part in each one. -5 times positive 1. Okay, now, it's good that I have 4 terms because we had 2 terms times 2 terms to get a total of 4 terms. Are any of those terms able to be put together now? Any terms to put together? Which ones?
X, 1x.
Yeah, 1x minus 5x. But this would make this kid's, I don't know, x squared. Help me with my North of Highway 3 math skills.
4, -4.
Minus 4x minus 5. Very good, guys. How about a show of hands? How many are on board with that right now? How many had that? Oh, good. You guys are awesome. Okay, any questions about that? You've got to be careful right here because when you multiply with something like this 5 right here, you've got to assume that this 5 is what type of 5, kids? Negative. Okay? How many are like, I think I've got this. Okay, let's look at another method here. I think that this is kind of cool here. Everybody have everything down on the first page? Anybody need more time with that? Any questions, first page right here? What's the name of that method we're using right now, kids?
FOIL.
FOIL, where F stands for what?
First,
Do the first, do the
outside,
outside, inside, last. Now, if you like that, you're okay with that, great. Some people like to use FOIL by multiplying binomials using a table. Okay, what's that, Sam?
We've done something similar to that, I think.
Have you seen something like this?
Graded multiply
Yes.
using a table.
You do use a table, but I'm going to be honest with you. I'm not the biggest fan in the world of this, but we're going to try this, okay? Some kids love this. This helps some kids tremendously. So let's try an example like this. I could, watch this right here, I could just do like we did with FOIL. I can take 2x times x, which is what, kids? 2x to the second. I could take 2x times the negative 3. For the outside, what would that be? Right, inside plus what? And then 3 times negative 3 would be a minus what? Okay, now sometimes kids, when people do this right here, and I'm not going to simplify this because I want to make a point here. Sometimes when people do FOIL methods, they get confused on what they've already multiplied together. So another way to maybe look at this is set up what's known as the box method. Okay, first of all, how many terms up here, kids, in this first? Okay, so what I do is I put a positive 2x here. Whoops. Up top, I'm going to put a positive 2x and a positive what? 3. So there's a 2x and a 3 right here. Okay? That's the first binomial going horizontally up there, that top row. Then, what do you think I'm going to put here and here? X and what?
negative 3.
Sometimes this helps kids to see it better when they multiply this stuff out. So in this first cell right here, I'm really taking what times what?
X.
Which is what? Okay, what's x times the 3? Okay, what's the negative 3 times the 2x? And then what's the negative 3 times the positive 3 here? Anyway, negative 9, good. Now kids, within those cells, are there any terms that are exactly alike? Okay, what are they?
Not
This and this, right? Okay. So in standard form, when I write this product out in standard form, what's it going to be? Two x squared, right? How about the ones in yellow? What are you going to combine them together? Minus 3 what?
X.
Yep. Very good. I don't know. Some people like this method better. You know which one I prefer? I like this one. I just do the first. I go boom, 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 boom. This is what I do. I just draw arrows. I start with the first one. I go here, here, and then I go here, here. That's what I like to do. Okay. But if you like that box method, use it. How many are like, yeah, I see that. How many like that better? I'm just curious. How many like the first way better? Whoa, I'm surprised. I thought you guys would definitely like this better, okay? Either way, would I get the same answer? Well, look at right here, kids. What's that going to combine to in the middle? So is this exactly the same as what we got over there? Certainly is, isn't it? I'm going to end up with 2x to the second minus 3x minus 9. They match. How many are like, Parson, I'm with you right now. Who's on the Parson train? Who's on the Parson train? Sweet. Who wants to blow the big whistle on the train? I'm going to ride the caboose and take a nap. Is that okay?
And eat donuts?
Eat donuts. Let's have donuts. Yes, definitely donuts. By the way, did you guys email me what kind you want to know yet? You need to do that.
Let's do that right now.
All right. I want you guys to try these two on your own right here, okay? I want to make sure you have this down, and then we'll look at example 4 here in a second. So take 3 minutes and 14 seconds to do this, all right? And get this done. Once you have 2 solutions on those, check with someone. If you want to do one, then check to make sure you're all in agreement to do it. But if you don't agree, what do you need to do?
Figure it out.
Figure it out. Talk with each other. Help each other out. La, 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 la. All aboard the choo-choo train. Wasn't that some show when you guys were young? Do you guys know what I'm talking about,
Yeah.
though?
Chuggington?
Yeah.
I watched you guys. I'm trying to see what we watched. It was good.
I'll watch it.
Did you guys know that little thing I shared yesterday with you about Ashton?
Aren't you like really close?
People donated almost $4,000 yesterday. That's pretty cool, isn't it? That's good people around here. Good people. That's exciting. He was pretty humble about it yesterday. That's cool. So if you happen to see him, send him well wishes, okay? Because I think October 21st is the day for him. Who needs more time in those two? Give me a show of hands, please. All right. I might have some people come around and do this. I might just give you the pads and write it. Sam, good job running last night, by the way.
Thank you. Thanks for coming.
Absolutely. I missed being around.
Yeah, that course wasn't hard. It was
That's probably the nicest place to run all year, I think.
yeah, old wine was really good too.
Whole line was good, yeah.
Let me get yourself.
No, I'm organizing. I'd probably lose if I played myself. I'm not very good at this.
He went and
Wait, do they have like the menu?
How are we doing on these guys? We need more time, or are we ready to roll?
Good.
Well, if you're done, get up, move around, see if you guys agree first. Guys, what do you want me to do? You want me to do the box method, or can I draw arrows and do it like I like to do it? How do you want me to? Arrows okay? All right.
Every hit by the
Yeah, I agree. Help me out, kids. What am I doing first here? How about a volunteer to talk to you?
Logan.
What?
Oh, never mind.
You want to talk me through this at all? Okay, Allie, I'm listening.
So you do x times x,
So those are the first ones right there, right? X times X would get you what?
x squared,
Okay.
and then you do x times -7,
X times -7, which is?
-7x,
All right.
and then you do 2 times x, which is 3x,
So those are the inside parts, right?
and then 3 times -7 times -4.
Okay. And guys, really what I'm going to do is this. The way I arrow this out, this came from the first, I'll put them down here. This came from the first right here, the first terms in each binomial, or each parentheses, if you will. This came from the outside of each, right? This came from the inside the beach, and this came from the wax, okay? I agree with all the multiplying. Are we in simplest standard form right now? What should that be, kids?
Combine negative 7x.
So what's our solution look like in the end? I didn't catch the middle part there, Ellie. Minus how much? 4x minus 21. Give me a show of hands, please. How many had x squared minus 4x minus 21 there? Okay, excellent. All right. Ellie, pick someone to talk me through the next one. Logan, I'm listening.
10x to the second.
Okay, I'm not going to draw arrows. You guys agree 10x to the second first? If I had to ask somebody where 10x to the second came from, where would you tell me? Where did that 10x to the second just come from? 2x, 5x. All right, carry on.
Minus 5x.
Okay.
So I did that out.
No, you're good. We'll see what happens here.
Yeah. Then minus 8x.
Okay.
Then plus 4.
Plus 4. Why plus 4?
And then 2 negatives.
Yep, negative 1 times negative 4 would really make what here, kids? Good catch. Are we done at this point?
No, it's simple.
I'm listening.
Negative 13x
Very good.
plus 4.
How many had 10x squared minus 13x plus 4? I'm going to be freaked out a little bit because you had negative 8x here first and negative 5x second. Did anybody have the order of those switch? But if I have the order of those middle terms switched, does it really matter? It doesn't, okay?
It just spelled FOIL.
Yeah. You spell file, feel, however you want to say that. All right, guys, let's see if we can accomplish example 4. This says multiply a binomial with a trinomial. This is where arrows start to come into play here. This is how I do it with a 2-term and a 3-term polynomial multiplied together. I start with this x right here, and I take x times this right here. What's x times x to the second going to get you? All right, how about x times the negative 4x? Minus 4x squared. But I also need to take that x times what else, kids? Negative 4 as well, which would be what? So I'm running out of room here, but that's okay. I can condense mine. So starting to stay in the same box, I'm going to have you guys try. Now I'm going to take everything times negative 3. So I take negative 3 times what, kids?
Negative or 2x to the second.
So this will be minus 3x squared on it. Then I'm going to take negative 3 times what, kids? Negative 4x, which is? Minus 12x. And then how about that negative 3 times the negative 4 here in the end?
Negative 3.
Yes. Okay, so give me a second to make some room so I don't go into the other box. You guys agree with my work there? All right, let's talk about combining terms. See an x to the third. Are there any more x to the thirds at all? So this will be x to the third. Got that. I see a negative 4x squared. Any other x squareds up there?
Yes. Negative 3.
I've got negative 4x squared and negative 3x squared to become,
Negative 7x.
yes. Okay, so what I like to do is kind of cross these out. Negative 4x squared, negative 3x squared would be negative 7x squared, right? I see a negative 4x. Anything that would combine with a negative 4x. So this becomes, and then, I'll swap. There it is. Okay. Now, guys, quick question. Was that a little bit more work? Was it a little more tedious, or was it a little bit longer of an answer.
It took longer, but it wasn't as hard as.
Yeah, but is the process kind of similar here? Pretty much the exact same thing, isn't it? Okay, so let's have you try one. Somebody give me a binomial to start with over here on the left.
2x plus 5.
I heard 2x plus 5 here first. Now give me a trinomial to multiply that to. Good. X minus 2x. I don't want to do that. X squared minus 2x plus 1. Okay? You guys see what you get there when you multiply that out, right? So I want to multiply a binomial with a trinomial. Same kind of process. How many terms will you start with initially? How many terms in the first one? 2. How many terms in the second one? So when you multiply everything together, you should have 6 terms before you start to simplify. Have a volunteer that wants to come to the board and do this one up here? You want it? Somebody want me to do it? All right, let's ask this question. Anybody have a solution yet? All right, help me out, friends. I'm going to start multiplying. What 2 terms am I going to multiply together first?
2x.
2x with the left.
X squared.
It helps me to draw arrows. So I'm going to take 2x times x squared, which would be 2x to the left. Yep. Right, because this is really 2x to the first power, right? Then I'm going to take 2x times negative 2x. Let's see. Positive 2 and negative 2 would be minus 4, wouldn't it? And then x times x would be 4x to the, anybody? 2x times 2x would make 4x to the, am I right so far? Okay, I need to take 2x times what next, kids? 1, which is what? Oh, come on, guys. 2x times 1. Plus 2x, right? Okay, now I need to take 5 times everything. What's 5 times the x squared?
5x.
Plus 5x squared. You take 5 times the negative 2x, which would be minus 10x. And then lastly, what times what, kids? What is 5 times 1?
5.
Plus 5. Hey, just a quick check to maybe know I'm right, but how many terms did I have when I did that first multiplication? How many terms do I have there that I just underlined?
6.
Could be expecting at 6?
Yep.
All right. So, talk to me, kids. I see a 2x cubed up here. That's my highest power. I'd like to leave stuff in standard form if I can. Are there any other x cubed terms in what we have here?
Yeah.
No, so it's just gonna say 2x to the left.
There.
Okay? Next highest power, 4x squared, 5x squared. What's negative 4x squared and positive 5x squared gonna combine to?
X.
So plus x squared. There's more positives than there are negatives. Those are exhausted. How about the 2x? Does that combine with anything?
8x. Or
Positive 8x or negative 8x?
negative.
Yep, there's more negatives than there are positives, so minus 8x. And then lastly, plus what here? Okay. And that would be your simplified standard form of the multiplication of that binomial and trinomial there, all right? I'm just curious, show of hands, how many are with me there? Now, when we start doing binomials and trinomials, is there more of a chance to make an error somewhere? Okay, one little mistake's going to throw you completely off, so just make sure you're paying attention to your multiplication. I have a question. Does it help you to draw the arrows?
Yeah.
Helps me a lot to draw the arrows, okay? So I would encourage you, if you can do it. If you get used to it, you're like, I don't need to do that arrow stuff anymore, I know where I'm going, then go ahead and do that, all right? Feeling pretty good? Okay. Let's try and get this last example done. I like this example, kids. So solving a real life problem up there. Guys, what kind of shape do you see shaded in purple there? It's trapezoid. It says the purple piece of stained glass has a trapezoidal shape. It says, write a polynomial that represents the what?
Area.
Okay. This is going to test you right here. Anybody recall the area formula for a trapezoid? Okay, somebody Google up area formula of a trapezoid for me. You got it there, Andrew?
Oh, well, did you, okay, didn't actually say, oh, yeah, there we go. A is equal to A plus B over 2 times B. Like capital A, I mean lower.
Okay, I don't really like that one. I'm going to go with this right here, okay? Okay, the area formula for a trapezoid. You guys have seen that before, I think, haven't you? Let me see what you had there.
It just replaced the B1 in the middle.
Okay, same thing, right? Okay, here's the deal. Guys, in a trapezoid, the two bases are going to be the sides that are my parallel sides. So this would be base 1 down here. This would be base 2. X minus 1 would be your height in this problem. Up there you have the area formula. It's half the sum of the bases times the height. So it says write a polynomial that represents the area of the what? Okay, ooh boy, this is going to get tricky. All right? This is going to become the following. This is going to equal to 1/2 times, okay, help me out, in parentheses, what's base 1?
6 inches.
It's in inches, but they're using what to represent base 1?
1 is
X, right? What's base 2? 3x minus what here?
6.
So base 1 would be x plus 3x minus 6 times my height, which is, ooh boy, kids. What's the height? All right, no problem. In that middle term, the x plus 3x minus 6, can I simplify that further? In other words, take a look at this middle parenthesis right here. X plus 3x would combine to what?
4.
So in the middle you have 4x minus 6, right? Times x minus 1. Now again, we want to write this out as a polynomial that represents the area of a piece of glass. This would be pretty good. I would say you've done a pretty good job, kids. But I'm going to say let's go further because do I really want those parentheses in there?
Nope.
No. Okay. Let's do this. Let's distribute 1/2 to this first set. What's half of 4x, kids? So this is the same as 2x minus, what's half of the negative 6 here? Okay, so those first two terms multiplied together becomes 2x minus 3. What do I still need to multiply by, guys? Oh, look, guys. Binomial on the left, binomial on the right, what do you think we're gonna do? What method are we gonna apply here now?
FOIL.
We're gonna FOIL this out to get an area formula. How about this? 2x times x would be what, kids? 2x times a negative 1 would be minus 2x. Inside's negative 3 and x would be minus 3x. What's my last term going to be? Plus 3. So part A, we're almost done here, kids. Any terms I can combine from where we're at after I've gotten rid of those parentheses?
Yep, it's negative 2x.
So 2x to the second minus what? 5x, good. Plus 3 is the area expression for this right here, okay? If I wanted to know the area of this trapezoid given these dimensions, its area would be represented or modeled by 2x squared minus 5x plus 3. That's what you would model it with. Now kids, read part B once you've got that written down. What's part B asking us?
And the base is sacrificial.
When the shorter base is how many inches? This is basically saying that short base is what value? That's basically saying, hey, anywhere where you have an x, plug in what value? 7, right? So my area in part B, when the shorter base is 7, is going to equal 2 times, we have the formula for the area right up here now, don't we? 2 times 7 squared minus 5 times 7 plus 3. All right, you guys help me. What is 7 squared there? 49 times that 2. What is that? 98. How about the 5 and 7? Minus 5 times 7 would be minus how much? 30 what? Plus what? Okay. Help me do some arithmetic. 98 minus 35, please. 63, good. And then 63 plus 3 more.
66.
66, yes, the area of this is 66 square what?
Inches.
Yes. Now guys, I want to show you this, and I want to show you that we are correct with what we just did up there. Guys, we used all of these formulas. We used this idea of foiling out to write or model the area of a trapezoid in polynomial form, specifically trinomial form. But let me show you something, kids. Go back to this drawing right up here. If I plug 7 in right down here, if this was 7 right here, what would that have been the height? What's 7 minus 1? 6. Help me up top here. What's 3 times 7 up here? 21 minus 6 would be 15. Okay, let's just talk. Guys, what's 15 plus 7? 22. Cut 22 in half. 11. Take 11 times a 6. There you at. O-M. Goodness. Whew. Good job, you guys. I sent out a new online page. Try and get in there and start working on that.